we've been dealing with VMs, virtual machines, the AWS virtual machines. Those are visual machines. The next level that we're going to start talking about is containerization. Then you talk about Docker. Docker is used to create containers. What we've been talking about all the while is virtual machines. So you go to your AWS account and you create a virtual machine. You can go to Azure, Microsoft Azure, and create a machine as well. You can go to Google Cloud and create a machine as well. Those are all virtual machines. Now, there's a difference between virtual machines and a container. So that's what I wanted to start with right now. The architecture of the virtual machine. You see, this is the infrastructure. So this is your laptop or any hardware that you're using, right? It has first is your laptop. Take it as your laptop. A layer in your laptop is what they call host operating system. The operating system that you're using, it could be Ubuntu operating system, it could be Mac operating system. That's a layer of that stands in between your hardware and your hypervisor. So the next layer, when you type on it communicates with what they call your host operating system, maybe Windows operating system is what you're using, or maybe Mac operating system, right? It does that communication. That's the first line of communication. Without that operating system, your system cannot work. Now, the next thing is a hypervisor, right? A hypervisor is more or less like an engine that actually makes your computer work. That's like an engine, more or less. Think of it as an engine. Now, on top of that engine, you can have different operating systems running on them, right? Oh, the first one is the host operating system. Now, you have different operating systems that you can install, like Ubuntu, this is your host operating system, which is Windows. This other one, like Ubuntu, like Red Hat, like you can install all those on top of your hypervisor. Now, on top of that, your hypervisor, then you have your binary codes. Your bin directories contains your binary codes, and the lib directory contains your libraries. You can have all those libraries. On top of those libraries are your application. So your application runs on your bin directories or libraries. Then your bin directories runs on your operating system, and your operating system runs on your hypervisor, and your hypervisor runs on your host operating system, which could be Windows or Mac generally. Then you have your infrastructure, which is your machine. So that is the build-up of a virtual machine, right? So that's virtual machine. And you also have, by the way, either it's the cloud or it's your real computer that you're using, is the same technology, right? The other one is somewhere, it's not in the cloud, by the way, it's where they call the data center, right? So when you hear that AWS is in the cloud, it's not actually in the cloud. They have data centers all over the world. I don't know if I had shared, well, we've not done AWS yet, so I probably have not shared that with you. So if you go to Google, type in AWS data centers. Right. Let me see, AWS data centers. Right, so, all right, this is what it looks like. This is what a data center is, right? They have data centers all over the world, right? And this is a typical data center, what it looks like, right? So when you say it's in the cloud, it's not actually in the cloud. It's on here on Earth, right? Where they build also, when you go to AWS, for example, or Oregon, if you log into Oregon, they have a data center in Oregon. So US West 2 is located in Oregon. So you're logging into one of the computers here. What you're logging into can perform the same functions that your laptop can perform, but you're using that one in the cloud, right? So that's what data center is. Okay, let's get back to lectures. So that's virtual machine. Then you have your containers. So the difference between your containers, if you look at this, right? You have even your containerization, say this is your laptop, right? Then you have the operating system, which is the operating system that you're using, right? It could be Windows, it could be Mac. Now, what goes in between your operating system and the applications or your binary files that you run is a Docker engine, is a kind of a Docker engine that substitutes where you have the hypervisor. So the difference between this and this is here you have the hypervisor, here you have Docker engine. But you see, in this Docker engine, right, you can run your binary files on top of your Docker engine without needing any operating system. You don't need the Linux, you don't need the EC2, you don't need Alpine, you don't need all those to go in between, right? You can just run your applications on top of your Docker engine. You have your binary files here. With your binary files, which are your executable files, you can run any application. So this gives it a lot of advantages, such that if you create different environments, right? If you create different environments, you can run your applications anywhere. You don't need to, right? Usually when if you in a virtual machine, if you create an environment, you create an application and run on one environment, right? You move the same application to run on a different environment. It may not run properly, it may not run well. So that's one of the problems we've been having in software development, moving an application or migrating an application from one environment to the other. For example, you are in the staging environment where you're doing all your QA, and you do all the testing on the software and it goes well. You move that software, the same code, the same artifact, to move it to production, and it doesn't run on production, right? So that's what software engineers have been battling over the years until they came to containerization. Containerization runs every application. It doesn't care what environment, it runs the same. So that's the major advantage between a virtual machine and a container, right? Now, there are other differences, there are other advantages, right? We'll get into it real quick. You'll see that this is, if you want to start a virtual machine, it takes forever to start. We'll get into when you start a Docker engine, when you start in container, in seconds, right? In milliseconds, right? The difference in speed of your container starting is the speed. Rather, this one is probably in minutes, right? This is milliseconds, or this probably milliseconds. So it's like day and night. The gap is a lot. So when it comes to speed, this is like a tiger, and this is like a tortoise, right? Okay, let's go to the next slide, right? I think this is what I was trying to explain. This is an elephant. The virtual machine is like an elephant when it comes to size, and like a Docker engine, which is a containerization, is like a mouse when it comes to size. So you hitch the file sizes you use in a VM is so large, but the file sizes in Docker, it's very small, right? When it comes to speed, virtual machine is like a tortoise. It's slow, whereas containers are like tiger, they're fast. Integration, when you want trying to integrate it with other applications, with other things, right? It's really, it doesn't go very well when it comes to virtual machine, right? But for containers, it works, integration works really well. You have some other things here. Total memory in case of virtual machines, right? In case of Dockers, these are some of the numbers, actual numbers that you can see when you are trying to deploy your applications. The memory used, the memory wasted, right? In virtual machine, for example, this legend, 4 gig, right? Memory wasted is like 2 gig, right? If your memory is 4 gigabyte, right? You can only use 3 gig and you waste 1 gig, right? So the total wastage on this machine is 7 gig. You only use 9 gig, right? But when you come to the containers, right? You're going to utilize all the memory space. So for example, 4 gig, all of it is going to, so you see this one is optimized, right? If you're using 3 gig of memory, everything is used. And when you compare what you're using here and the waste here, you see you can use 9 gigabyte here, and here you have 9 gigabyte used, but you're wasting 7 gig, right? So that's the trade-off between virtual machine and containers. So those are the major differences, right? So that takes us to the next thing that I want to discuss, which is microservices, right? Now, when we get to microservices, you have business logic functions. Microservices, let me explain what microservices is. And I can explain this before I get into explaining all of this with what is a monolithic application and what's a microservices, right? So we used to run or build software as a monolithic application, but now we're building software as a microservices, okay? Now, let me explain monolithic application. Monolithic application is, for example, this is an application that you want to write, and this is a code that you want to write to get this application. All this code, this is install UI, this is the initial UI, and in this UI, you have the catalog service, you have the order service, you have the payment, you have the product, you have the order, you have the payments. For example, this is an e-commerce website that we're trying to develop. All these codes are written as one, right? It's one block of code, not one block of code. It could be in modules, but they are all contained in one code. And then you have a database that it goes to, right? Now, this is your text browser. You're browsing this and you're passing it through a load balancer, or you're using a mobile phone. So this monolithic application. Now, if anything goes wrong with maybe your catalog service, what is going to happen to your application? You have to stop the entire application. You have to stop everything here. You have to pull down your application, right? Now your customers will be screaming for you to fix one code that is causing problem in a catalog service, because you could create all this as modules, right? Now, if anything happens here, you have to shut down the entire application, right? Your customers will be stranded. If it's a banking application, so it means people are trying to withdraw cash will not be able to withdraw cash because you're trying to service something in a part of the application. So that's what is called monolithic application. It has a lot of disadvantages, okay? So going from monolithic application, right, which is really good if you're running a VM, it's super in VMs. Monolithic applications we use in VMs, virtual machines, they run very well. We move from microservices, from monolithic application to microservices architecture. In microservices architecture, right, instead of combining all these different models of your application to be one, you separate them. By the way, in doing your monolithic application, you're using one language. One language could be Go language, Java language to write your application. This is just one language. In microservices, you can use different languages. See, all these services are separated, like account services, inventory service, shipping, storefronts, right? This has different APIs. So you call them REST APIs. You create them as a REST API, right? Differently, separately, so that if account services has an issue, right, you can take out the account services model. You're not affecting any of these other models. You fix the account services model, right, and put it back. And by the way, with containerization, if you're using Kubernetes, you can use a strategy that's called rollout strategy. Now, or you can use a blue-green strategy while you're working on the other one, right, fixing the problem. This one is still running, and you can do a rollout, right? Rollout. Kubernetes helps you to do a rollout whereby it's not going to take out the application that's running. The application is still running, and it will do a switch automatically, and all the users will start using the new application without them even noticing that anything is happening, right? That's the power of containerization, right? So microservices, let me show you a typical example of a microservice application, right? This is the microservices application. This is the front end, which is the front end of your application. That's, for example, you're trying to Amazon website, right? This is actually a real application that was built. For example, this is like an e-commerce website. Amazon, this is a storefront, right? It has a load generator here. It has a checkout. You know, when you go, you do your checkout, but before you do your checkout, you have to get into the product catalog, right? It gives you a recommendation here. This is an AI giving you a recommendation of what to buy. This is an ad running on the side to show you what discounts are going on in the store. Now you can, with the recommendation, you can go to the product catalog. In the product catalog, you can select what you need to, right? And you can put all of those in your cart, right? You have a cart here, you have a small database here, Redis cache that is holding up your items that you put in your cart. From your cart, you can do a checkout, right? You can do a checkout, right? The checkout would communicate with, once you check out, you communicate with your shipping. What kind of shipping do you want to use, right? Then, of course, it's checking the currency that you're using. You want to buy in dollars, you want to buy in pound sterling, you want to buy in Naira, right? It has that model as well that is communicating with the front end. And you have a payment service here. How do you want to pay? Credit card, right? What credit card, Visa, MasterCard, and it also has an email also to communicate with you once you complete your checkout. So this is, let me show you a live application of this. Not a live application, but the codes. Where is my, let me go to, I have the whole codes in my GitHub account. So let me show it to you. Yeah, Google put this together, microservices demo. Yeah, Google put this together. This is the entire, if you have a Google account, you can actually run this application and it runs, right? This is a boutique, it's online boutique, right? And this is the actual homepage of that home line. By the time you complete putting this together, this is what you will see in the homepage. And this is the checkout screen, right? And this is the diagram that I just showed you, right? This is the architecture. So by the end of it all, right, you have a complete website that looks like this. This is built on microservices, okay? So that's an example of a microservices that use containerization in building, right, against the monolithic architecture that we've been using. Okay, does that make sense? Any question on monolithic and microservices? Okay. Now, the advantages of this microservices that I must have mentioned it to you guys, language independence, right? Like I said, all these applications, you can use Java to develop your ad. You can use C++ for recommendation. You can use Java. You can use C Sharp. You can use, this can be run on different languages, different program languages, independent of each other. But with containerization, you can communicate with all those. It doesn't need to be one programming language, right? So if you get to your organization and part of what they need you to develop, you belong to a team and you people are in charge of developing the shipping, and all the developer knows how to write is maybe Java language, programming language. He doesn't need to go learn Go language. He has to use the Java language to develop the shipping application, right? Because it doesn't matter. Another developer could know Go language. He's going to use that for product catalog. Once that is done, when you put it in when you containerize the entire application, the whole application, right, it runs seamlessly, right? So containerization, one of the advantages is language independence. It's fast iteration, right? So because it's microservices, you can do iteration of, you can start developing your application, then start adding features iteratively, right? If you don't complete it, you can send the first page, right, for customers to start using. Then you start developing other features, right, and add features to them, right? So it's iterative in nature. You have that ability, and you can work in small teams, right? So in monolithic application, remember when we started when we started the introduction of DevOps, we talk about waterfall application. And waterfall application actually, in waterfall application, monolithic application is what they used to, because you have a bunch of developers trying to develop all this, right? And the developers, some developers will wait for these developers to finish before they start the operation, and so on and so forth, right? But in microservices, you work in small team. A small team is going to develop this. Small team is going to develop this. Small team, right? You work in small teams, and it's faster development rather than the whole team trying to, big giant team trying to wait for this to finish before this can be done, before this can be done, like you have in the waterfall methodology. Yeah. Fault tolerance isolation. So if anything happens to your payment, your email services are still working, your checkout is still working, your recommendation, every other thing is working. So it has what is called fault tolerance, right? Payment services not working doesn't bring down the entire application, right? Your customers can still go in and see what they want to see and still work on the other applications in your software, right? If shipping is down, it doesn't take down your entire application, right? So that's fault tolerance. It pairs well with container. Well, of course, microservices, right, is meant, and it's scalable, right? And the scalability, let me talk to you about scalability. For example, you have users. For example, it's Thanksgiving, and everyone wants to shop. I mean, yeah, everything is in half prices, right? So because you're scaling each of the applications differently, right? So you can introduce what they call auto scaling, whereby most of your customers are coming, the traffic is coming into your product catalog. Everybody wants to see what you have. So what are you going to do to the product catalog? You have to scale out your product catalog, right? Scale it out so that so many traffic doesn't take down just one container. You can scale this out. Now, scaling this out doesn't scale because shipping, right? Most people that just look at your product catalog, they are not going to check out, they are not going to ship, right? Maybe they are not going to make payments. So you don't need to scale these ones. You're only scaling this. What would happen if this were to be a monolithic application, right? If you have to scale, because your auto scaler is here, you're going to scale all this. And scaling application is money, right? When you scale all this, it's money. Now, think of you just scaling this. You're not scaling every application here. So you save a lot of money not scaling anything. If, yeah, this is what you need to scale, then you scale this. Maybe a lot of customers are buying things now, they're putting them in cart, right? You have a Redis cache here, which is a small database that holds what you have in the cart, right? So you get to the cart, right? You can scale your database, you can scale your cache as well. You don't need to scale everything. You don't need to scale shipping or currency and every other thing. So it's scaling is independent of the application, right? So there's a lot of advantages there as well. So that's another advantage of microservices, right? So this is a big one. It's a big plus. And we also have disadvantages of microservices as well. It's complex, right? So all these services that you see here, they have to talk to each other, right? Like you see it here. You see, they're all connected. You cannot have product, you cannot have recommendation without being connected to the product catalog. If they make recommendation, you have to go see the product catalog, right? You see the product catalog, you have to check it out, right? After you check it out, put it in the cart first or checkout. So you see, they are all connected. Payment services, email. Now, this is what it looks like in real life. They have to talk to each other. So there has to be some networking that's going on in between each of the services, right? So that they can talk to each other. And you need to have some kind of what they call, right? Docker comes with what they call bridge network. The default network in Docker is called bridge network. You have to configure this bridge network to be able to have this communication going, right? So it's complex. Now there's an overhead of database and server, right? There's a low overhead because you have a lot of containers running. If you have to scale, you have to scale. See, database and servers, it could be that in every services, it has a database, right? That will store information, that will hold information. So you could have a lot of databases that otherwise in monolithic applications, see, you only have one database that holds every information. But in microservices, the disadvantage is each of the application will have its own database, right? See, this is DB, these are databases, right? So that's another disadvantage that you have in microservices. Overall, the advantage of the microservices outweighs the disadvantage of it. Okay? So that's microservices, the advantages and disadvantages of microservices. So that takes us to what we want to learn. And the first model is the introduction to Docker. So the question is, what's Docker? Right, we look at what Docker is, look at Docker's role in DevOps and software development, and we already seen the difference between Docker and virtualization, which is virtual machine and containerization, the key differences. So we've taken care of this one, but let's go back and define what Docker is. So if the question is, if they ask you what's Docker, right, you'll be able to. So it has it here. Docker is an open source platform that automates the deployment, scaling, and management of application within a container. So it's a platform that automates the deployment, scaling, and management of applications within a container. So containers are lightweight, portable, and self-sufficient unit that package applications and their dependencies together, ensuring consistent behavior across different environments from development to production. So that's what I was explaining to you, that in a container, right, it behaves the same way. I mean, if you have a container, you move it to any environment, it works the same way. The behavior pattern is the same, and it's lightweight, it's portable, right, and it's self-sufficient unit, right. So that's a container, right. Docker is it's a platform that automates the deployment and scaling and management of the application within a container. So that's Docker, right. It's an open source platform, right. You should know that it's an open source platform, meaning that it's open. Anyone can go in and contribute codes. You have a community that maintains it, that you can also contribute. If you want to be a contributor to Docker, you can also go in and contribute and develop that application. Okay, so that's Docker. There are key features in Docker that I want to introduce you to. Docker allows applications and their dependencies to be packaged into a container. So when you talk about software, what's a software? The software has one part is an application, and the application also have dependencies, right? So when we're doing Maven, right, I told you the dependencies that Maven has, right? Even though the codes are written, the dependencies that actually you have to, right? Dependencies that you have to go with your codes to be able to make it run effectively. So when we get into image, you create an image in Docker, right? In Docker, you create an image. The combination of the image and the dependencies creates a container, right? The image, you can have the image and you push the image, right, to your GitHub, all right? Then you can deploy the image. When you deploy the image, it becomes a container, right? So by the time it becomes a container, it has dependencies packaged into it, and it becomes a container. Now it runs as an application, right? Isolation. Containers provide process and file system level isolation, right? allowing multiple applications to run on the same host without interfering with each other. We'll get into all that isolation, the way you isolate applications, maybe in Kubernetes, you use namespace to isolate applications, right? We'll get into all that. So it allows you to do that. It provides that, it has that provision whereby you can separate your applications and run them as hosts using host names. Portability, Docker containers can run on any platform. Like I explained, that's portability, ability to run your application in any platform, right? Including cloud services, virtual machines, or physical servers, right? That's what portability means. Resource efficiency, containers share the host operating system kernel, reducing overhead compared to traditional virtualization, right? We spoke about this earlier on, the efficiency it has compared to your virtual machines, right? So it runs more efficiently than your virtual machines. I show you the memory capacity that it conserves when you're running on container compared to running on a virtual machine. Scalability. So I also talk about scalability. We've talked about scalability, how you can scale vertically and horizontally. So that takes care of that. Now, Docker image, you can version your Docker. There's your images. That's another thing, because your images are stored, like you store things in the GitHub. We also have Docker Hub that stores images. So your images can be created. You create a Docker image using a Docker file, right? From your Docker file, then you run a Docker build and it creates the images. And you can version your images, right? Version 1.1, version 1.2, and so on and so forth. You use a tag to create versions. Then you can version control them, just like you're using a version control system. What's the version control system that we use? Git, right? You can also version your images using Docker and store them in Docker Hub. Whenever you want to use it or you want to modify a particular version, you can create new versions for it. DevOps enablement. Docker streamlines the collaboration between development and operations teams by providing consistent environment for development, testing, production, and so on and so forth. So this goes into the portability that I was telling you about, because DevOps typically, because they're the ones that are designing and developing the application, they want different environment. They want a development environment, experimental environment, development environment, stage environment, testing environment, and so on and so forth. So it actually makes the job of the DevOps engineer very seamless. Microservices architecture, we look at the microservices architecture. Docker containers are well suited for microservices. So we look at microservices. The containers, right, is well suited for microservices. Imagine you want to run all this on a virtual machine, right? All these are separate machines, right? And how inefficient the virtual machines are, and you're trying to create virtual machines for all this to run. It will cost you a whole lot of money, right? Virtual machines are very expensive compared to the use of containers, and very inefficient, right, when it compared to containers. So where were we? Right, so it's very suitable for microservices compared to, right, it's not very good for monolithic applications though. Virtual machines are good for monolithic applications, but microservices is the best thing that can ever happen to microservices methodology. I talk about fast iteration, right? Docker fast startup times and isolation make it ideal for rapid development and testing cycles because they're very quick. Like we just debuted a new application in my organization. Today is the first time that we're launching it, right? And we're using containerization throughout, right? That's one of the product. I'm the product manager, so I'm very proud of myself for that being done. So we're using Docker, we're using containerization, and it's like a spaghetti, right? The amount of content, the number of containers that we're using makes it look more or less like this. By the time you look at the architecture, it's something like this, right? It's very fascinating, very, very inspiring, I would say, seeing all that come together, and we have a well-built application. It's not, I was trying to see if I can, it's not out for the public yet. Once they make it, the official launch is on February 5th. We have some conference going on, they call it App World. So that's when the first time they everybody outside the organization will be able to. Once I'm able to, I'll show it to you guys. I think next week, February 5th is when? Let me see, by the way. February 5th is next week, Monday, right? So by next weekend, if I'm able to get to the website, if it's made public, I'll let you guys take a look at it and I'll show you how it runs. Okay, so that's those are some of the key features uh, of a container, and of course Docker, right? If you really want to learn containerization, it's good to have a good foundation on what containers are, the advantages and disadvantages of it, what it actually does. So that's why I'm taking time to explain this, because in most when you go to interviews and it has to do with Docker and Kubernetes, apart from the fact that they might give you an assignment, take home assignment to go do, most of the interviews are theories, right? But for you to actually answer those questions, you need to know the background. If you understand the fundamentals of how containers work, you might be able to scale through this in those interviews. No one is going to ask you to write a Docker file and sit down there and write a Docker file. All they're going to ask you to do are theories. So that's why I spend time to get into the background, give you enough information so you can read. You can also read all this by yourself and understand. Okay. So any question before we continue? Okay. So these are some of the roles that Docker plays in software development. Some of these roles are something that we've talked about while we were looking at Docker, trying to explain Docker. Some of these, for example, consistent across every environment. So that brings that enablement to the software development environment, right? The ability to run all these your application on different environments gives it an upper hand in software development. Fast and reliable build, right? You can create Docker file. From Docker file, you create an image, and from that image, you can create your container in, depending on the time, really fast turnaround. You have your application running. Okay, so that fast and reliable build is very, very important. It helps in software development. Rapid testing, right? It helps in rapid testing. You can test your application as you're building it. So this helps in continuous testing, which is part of continuous deployment. If you test, you can deploy very quickly because you're on the staging. In your staging, you do all the tests that you need to call QA tests. And once you test it and it's running, automated test, right? Your automated end-to-end test, you can move that application to production immediately, right? If it's working well. Okay. Rapid testing, continuous integration, and continuous deployment. So continuously you integrate all what we did in the pipeline. You introduce this into your CI/CD pipeline, and you can have that continuous integration, continuous testing, and continuous deployment. Efficient collaboration. Docker images serve as common artifact that can be shared between developers. So Docker images are shared in Docker Hub. So any developer can pull this, right? And look at the codes and learn from the codes and collaborate and add and so on and so forth, right? So it helps with that collaboration that everybody, maybe in a team, you're developing the same code. So you can pull this code, the same code base, and you can pull the same image. You can modify the Docker file and also modify the images as well, right? Isolation and security. Containers provide isolation between applications, reducing the risk of conflicts. Like I showed you, security vulnerabilities. So if one application is vulnerable, for example, this is this one. If production catalog application is vulnerable to attack, this one is not vulnerable, right? So it isolates this application, and you can actually secure this application. You can put your WAF web application firewalls in each of these applications and protect them individually, so that if an attacker is able to get in here, an attacker cannot attack this, right? And so on and so forth, right? So you can do that as well. So it helps with that isolation and security to be taken care of. We've already done this. Okay. Then scalability. We already talked about scalability. Docker's lightweight nature and efficient resource utilization make it easy to scale applications horizontally by launching multiple containers, right? Container orchestration tools like Kubernetes further enhance the scalability, right? You can use Kubernetes as well to set a replica of what you want. You want 5 replicas of your application. Every time, 5 replicas will be running. You can put it on auto, right? So that you can scale up and down as traffic increases, right? You can version control it and can you roll back. If the application is not running well, you can roll it back, right? And roll new applications on, right? You can set a rollout strategy, right? A deployment strategy. It could be blueprint deployment. This could be what I call, what are these strategies? I just draw blank right now. Well, you can do it. A rollout strategy is Kubernetes default strategy, right? You can roll out and you can roll back. That's the default. You can do blue green. The other one is, what is it called? Kadi. It will come back to me. I'm drawing blank right now. There's another strategy. There are about 4 strategies that you can use to deploy your application, right? So you can do that as well. Infrastructure as a code. So you can create an infrastructure as a code, right? You can use it as infrastructure as a code. You can in Terraform, and you can actually use Terraform. Ansible, you can use Ansible to deploy your Docker file as well, right? You can use Ansible, which is also a code, infrastructure code, can actually build the infrastructure and deploy the application as well as a Docker file. Okay, more on this. Microservices architecture support microservices. We've talked about this. The flexibility of deployment. Docker containers can be easily deployed across various cloud providers and on-prem environments. Resource optimization, we talk about the optimization compared to virtual machines. So that's part of it as well. I want to run through this and so that by next time when we meet, we start doing hands-on on Docker. Okay, so this is Docker virtualization, the differences. We've already talked about these differences when I was explaining that, but let me run through it, right? Docker uses containerization to package an application. That's the architecture. The architecture has, Docker has what they call virtualization, involves, wait a minute, what am I? No, these are the differences, right? So these differences, you talk about the architecture. Now you have Docker uses container, virtualization is virtual machine, right? Resource efficiency, Docker is lightweight, it's very efficient. Virtual machines are heavy, they are not efficient. Isolation, containers provide process level isolation by the use of namespaces and control groups, right? VM offers stronger isolation as they have separate operating system instances. Like I showed you, you can use Ubuntu, um, uh, Red Hat, Alpine, and so on and so forth. Virtual machine also has isolation, but in Docker and containerization, you use namespace to do the isolation. The deployment speed, the advantage Docker has, Docker can be spun up in seconds. Virtual machines take longer to boot up because they need to start up a full operating instance before they can start up. So that's some of the differences. You talk about footprints. Docker container images are very small. For example, if you're using the Alpine images, they also have what they call the thin slim or the slim images. They are very small when it comes to the size. If you compare them to the size of the virtual machines, they require larger storage for the images. Then when it comes to management, Docker uses orchestration tools like Kubernetes to orchestrate the containers. Virtual machines are managed using hypervisors, like I showed you in the architecture. Okay, ecosystem, Docker Hub, and other container registries offer a vast collection of pre-built images. So you have all the images containing. You can use private registry or you can use a public registry like Docker Hub, right? Virtualization, VMs require manual configuration, right? All the configurations are manual, and there's less emphasis on centralized repository for pre-built images. Okay, and you have use cases. Docker is well suited for microservices. Virtual machine is better for scenarios with strong isolation, compatibility with legacy systems, or running multiple different operating system instances. Then when it comes to migration, you have containers are highly portable. VM can be less portable due to variations in hypervisors, right? So those are some of the differences. All this will be made available for you so you can read on your own, the theoretical part of it, and understand by yourself as well. So let's get into the next model, which is Docker fundamentals. We look at Docker architecture. We look at Docker components, the images, containers, network, and volumes. So when it comes to Docker, these are the 4 things that you should keep in mind. If you know these 4 things, first is the images, second one is the containers, the volumes, and the networks. Those are the things that runs Docker. All right. If you know these 4 things, then you know containerization. The next level will be how to orchestrate the containerization, which is the use of Kubernetes. Okay. So we'll also talk about Docker Hub. We'll have you register in Docker Hub so you have an account. So you can have an account just like you created a GitHub account. You also create a Docker Hub account. Then we'll learn basic Docker command. Docker commands are very basic and easy. It all starts with a Docker run, Docker build, Docker pull, Docker push, right? Docker stop, Docker remove images, RMI, and so on and so forth. It's very easy and simple to run. It's just like a Linux command. You can actually say Docker images ls, right? When you want to list your directories and files, you do ls. You can do Docker images ls, right? You can do Docker container ls, or you can do Docker ps will list all the containers as well. So it's very simple to learn and understand. Okay, this is the architecture of Docker, right? You have a client here, which is a Docker build. You can run, these are the clients. These are the commands that you run. Docker build, Docker pull, Docker runs. Clients means this is clients, call yourself a client. Your computer is a client. The applications, the commands that you're going to run in the interface, the clients, they call it client server. That's you. Then you have the host server. The host server is the other thing that's hosting Docker, right? So whenever they talk about client server, they're talking about your laptop, the interface that's running in your laptop, what you're using to communicate with the host. When you talk about client server, that's what you're talking about. In other words, you are the client, you are the one interfacing. You're using that interface you're the one to give these commands. Okay, so this is Docker host, and it has the images, right? You could have an Ubuntu image, you have OpenStack images. These are images, you have Docker daemons here, and these are your containers. These containers are built and they become containers, right? You have images here, and these are containers, right? From your images, could be an Ubuntu image, it could be OpenStack image, and these images are built to become a container. And this is Docker registry. And where do you pull these images from, right? These images are pulled from your Docker container. It could be a Docker registry, you can call it container as well. This could be a GitHub, right? And you pull this image in here, this image becomes, you can build it into a container. So it's a simple three tier stages. You have the client, have the host, and you have the registry. All the images, when you build, you push the images to your Docker Hub. And once you want to use the images, you can pull the images. And there are pre-built images, thousands of images that are in your Docker Hub that can just pull and pull them and build your application, right? So we want to get into the details of the architecture. If you want to learn more about, so this is the client. Docker client is the command line tool or graphical interface that interact with the Docker daemon. Docker daemon, this is actually the engine. It's also called the Docker engine. It's the background service that manages Docker containers on a host system. So what is it responsible for? Yeah, it's responsible for the building, running, and managing the containers. Right? The daemon listens to Docker API requests and communicates with the underlying operating systems to execute the container that is operating, right? So that's what it does. It actually manages the entire thing. It helps with the management, helps with communications, and so on and so forth. So that's a Docker daemon, is the engine that actually runs all your commands, your events. It runs everything that's going on. So Docker daemon is right here. There's a Docker daemon that's doing, so it's doing all the coordination, the communication between your clients and your registry, and sending all this, creating this to container to be created, and so on and so forth. So that's the engine that is orchestrating or managing all this to happen. Okay, then you have the Docker images. Docker images are read-only template that defines the applications, right? It's dependencies and the execution environment. So it has the template, it has the application, it also has the dependencies incorporated into it. So images are created from a set of instructions specified, and that set of instructions is called the Docker file, right? I'll show you what a Docker file looks like. A Docker file is a set of instructions that you go from, you pull a base image, from that base image, then you give sets of instructions, and that set of instructions, the best image also comes with some dependency, right? With that, you build this set of instructions, that set of instructions, you can build it and it becomes an image. From the image, then you can create a container. And so this is a container. Docker containers are instances of Docker images. They are instances of a Docker. They are running instances of a Docker image that runs as isolation and lightweight environment. So that's what a container is. Okay, Docker architecture we still continue with. So the interaction among these components follows this general flow. Image creation, so you create the image storage, when you create the image, you store the image. And where do you store the image? You store the image in Docker Hub, right? Then you get into container creation, right? Containers are created from Docker images using Docker clients, right? From there, you create the container, right? Then container runtime. Containers run in isolated environment on host system with their own system processes, networks, and so on and so forth, right? So first, you create a Docker file. Then from a Docker file, you create the image. From the image, you create a container, and you can run the container on different environments. That's the workflow. The Docker clients can issue commands to interact with containers. So you can interact with the container. You can restart your container. Isolation and resource control. Containers offer process level isolation. So you can separate your containers using namespace. We'll talk about that. Docker provides options to control the resource utilization, the network settings, security, and so on and so forth. Then there's a communication that has to go on, right? I showed you when you create those microservices, you have to have communication, something that communicates with different applications. And that the default network is a bridge network. This is a bridge network. You also have another network type that's called overlay networks, right? And you have what is also called a host network. Overlay network or host network. You have three networks. Let me see, hold on. We'll get into networking real quick. Okay, we'll get into networking, right? You have one. Actually, one is used in Docker Swarm, but we're not going to do Docker Swarm. We are going to skip Docker Swarm because what Docker Swarm does is Kubernetes does the same thing, which is orchestration. And most organizations are not using Docker Swarm. They're all using Kubernetes. So I'm not going to waste your time with Docker Swarm. We'll just move into. But if you want to learn about Docker Swarm, I have a video that I did with class 001 that has Docker Swarm. I'll post that video. If you're interested, you can spend time and watch it. It's not bad to know what it does and how you can use Docker Swarm. But it takes a whole lot of time to know it. But I don't want to waste your time because you know it, but you'll probably never use it, right? So I'm moving to Kubernetes that I know that you guys would use, okay? So we'll get back into the networking. I think I have a slide for different networking, or different network that runs Docker. So you have to monitor your application once it's running. So Docker provides the tools for monitoring container resources, usage collection. So you have metrics, you have logs, you also have traces, right, as well. Those are the three components of monitoring. So that would go. We'll touch a little bit when we get into Kubernetes by using Prometheus and Grafana. We'll touch a little bit into it, but we cannot get, because that's a separate class. It can take a whole 3 months to even learn monitoring, monitoring Prometheus and Grafana. Okay, scaling orchestration. There's another architecture. In this architecture, scaling orchestration is one part of it. Like I said, Kubernetes is what you typically use. You can also use Docker Swarm for orchestration, but we're not going to do Docker Swarm. We're going to do Kubernetes, like I said. So these tools enable automation deployment, scaling, load balancing, and other advanced features for containerized applications. Okay. I'm sorry I'm not giving you guys a break these days because I think we can sit through 2 hours without a problem. So let's keep going. I want to trying to make sure I finish with the theory at least today, so we can get into the lab and start getting our hands. Too much theory could be boring. Okay, so components of Docker, the Docker images. Docker images are the fundamental building blocks of containers, right? So you have component is a Docker image. And how do you get the image? You get the image from a Docker file, right? Which contains a set of instructions to create the image. Then you have a Docker container. More or less, this is repeatable, right? So you have a Docker container. You know what a container is right by now, so I'm not going to repeat that again. Another component is a Docker volume. So Docker volumes are used to manage what is called persistent volumes or persistent data, right? Typically, they call it persistent volume. Now, what is called persistent volume is because when it collects data, it holds the data. You can go back and see the data. When you have a database, every database has what is called a volume. So when you type information, for example, you want to order some things from Amazon, right? You go to their catalog, you select what you want to buy, and you move those things to the cart, right? Once they move to the cart, right, it stays in the cart, right? What is keeping it in the card, those data in the card, is what is called persistence volume. It has some kind of volume, which is more or less a database. It's a database and has a storage. Volume is the storage. So that storage holds that thing, that product that you selected and put in the card. It keeps it there. It's called persistence volume. Otherwise, so if you move back, right, you move back from that card, you move to a different, you come back to the card, your products are still there in the card. They are there because you have what is called a persistent volume, right? That persistent volume holds that data in there. Otherwise, when you browse out of that that application, maybe the card, and when you come back, if you didn't have that persistent volume in there, those things that you moved to the card would not be there. So that is what is called persistent volume. It's a storage that holds the data so that you can go back and forth and come back, and the data, it returns the data until you move that data out. So that is persistence volume, in other words, right? Then you have Docker network. That's another component. I told you about network is all about for communication, right? Now you have the bridge network, right, which is the default network. You have the host network. You also have what they call the overlay network. So these are the three that I was talking about. You have the bridge network, which is the default network for the container. If they ask in an interview, what is the default network for containers or Docker? The default network is bridge network. Remember that. Then you have host network. Containers share the host network stack, right? You can also have host network, which is the default network that you have to create. Now you also have overlay network. You can also have overlay, what's called overlay network, right? Overlay network is usually used in microservices, and you use it in something like Docker Swarm, right? You use it in Docker Swarm, right, which we're not going to talk about. But know that there are three networks. We have one is the bridge network, the host network, and the overlay network. Okay. We'll get through this real quick. So Docker Hub and registries. So Docker Hub is a place that you store your images, right? All the images are stored in Docker Hub. And also, you can also have private registries. You can also have private registries. Private registries are not public. Some organizations will have their private registries where you can store your data without making it public. So if you store your data in Docker Hub is a public repository. You can make it private though, right? But the privacy it contains, some organizations don't really trust if it's a secret. For example, you're developing a new software and it has all your trade secrets in the software. You don't want to put it in a public repository. You want to put it in a private repository. So most organizations have their own private repository, right? So you put your information. But if you're developing an application for the whole wide world to use, right? An application that, where do you want to put it? You want to put it in a public repository where they can go download the application and use, right? So some of the public-facing, customer-facing applications are contained in Docker Hub. The images are there, so they just go pull the image and build their application, right? So, for example, if you want to create SonarQube, right? SonarQube has an image. If you want to create Nexus, it has an image in Docker Hub, and so on and so forth. So you can go to Docker Hub and pull those images and build your containers, right? So Docker Hub is that one. You have images repository. Docker Hub allows users to create repositories for Docker images. Official images, they have what they call official images. These official images are images that are created by known organizations, right? So whenever you want to pull an image, for example, SonarQube, an organization will create what is called an official image, right? There are other people that create images as well. They can create images like a SonarQube image, but the best practice is for you to go and pull official image. Why are you pulling official image? Because you have a set of organizations, set of people in an organization that maintains that official image. They go in and do patch on it. They go in and maintain it. They version it. They make sure it's working. They make sure nothing is broken in it. That's why it's an official image. They spend money to maintain it for the public to use. User repositories, users and organizations can create their own repositories to store custom Docker images as well. And we also public and private repositories. Docker Hub support both public and repositories accessible to everyone, and private repositories restricted to authorized users. Automated build. Users can set up automated builds linked to GitHub, right? GitHub or Bitbucket repositories. So you set automatic. So you connect your GitHub. For example, you have a CI/CD pipeline. You connect your CI/CD pipeline to the Docker Hub repository, whereby when you're running your pipeline can pull the image, right? Build the image and turn the image to a container, right? In your CI/CD pipeline, right? It also has what is called a webhook. I showed a webhook in GitHub, right? Where you can trigger, right? Once you trigger a Git can also trigger a webhook in Docker Hub, and Docker Hub, it will automatically pull the images, right? And helps you in the pipeline to build your container. Well, collaboration organization can collaborate on Docker images, share them with teams and members. If you're working in a team, I explained that before. Everyone can go and pull the images from a Docker Hub and use that images and create their containers for different environments. Let me see if we have any question from this. Do we really understand what this container is? Or do we understand what Docker is at this point? Any question before we continue? Okay. This is an example of what the registry looks like, right? So here, this is a container engine. So this is for example, Docker Hub or a registry, private registry. So you can pull this image, right? Right, this is image, right? You do Docker build command and it will build the image for you. Then you can do a Docker run, right? Docker run would create a container, right? Then this is where you start. You have a Docker file. This Docker file, you can build these images, right? You can, from these images, if you don't need to push it to Docker Hub, you can use these images and create a container, right? Images instance running an app process in same system. So this is the same system. If you don't want to use it in the same system while you're running your images, you can push it to Docker Hub or registry or Docker Hub, right? You can push it here. Once you push it here, you can pull this image back if you want to run it in a different environment. You can pull it to this other environment, right? Same image, and run a container. A container is actually the application that you're running. Okay. So this is container registry.
I have a question. Is the container our finished product?
You have a lot of chatter on the background. Can't really hear you. You have a TV already running on the background. That's all.
Yeah, let me lower the volume.
Yeah, so you're listening to TV while you're listening to the class, huh? Okay, go ahead with your question then. Hello, are you there?
Yeah, I'm here. Sorry. No, I was asking, is our container our finished product? Because I heard you say it acts as an application.
Yeah, when you run a container, when you finally have a container and an image, container is actually becomes the application, right? It becomes an application. In Docker, from Docker, you can actually deploy your application from Docker, right? Docker comes with, you can create a static website that you can actually deploy your application, but it's a static website. You cannot scale it up or down, right? But it actually has more or less something like it's not a Tomcat server. It comes with some kind of server that would deploy your application, but it's static. You cannot scale it. You cannot do anything. That's why you introduce Kubernetes. So Kubernetes can take that container that's built and you can scale it, you can manage it, you can orchestrate it, scale it up, scale it down, manage it as you want it. Yes.
Yeah, that makes sense.
Good.
Thank you.
Yeah. So again, the Docker image contains all the elements of the application. Docker image is, they call it an image, but it contains all the components of the application. It contains the code and also the dependencies wrapped together, right? All the dependencies, for example, when we're writing, do you see when we did when we're doing Maven, right? When you look at those codes in Maven, those code has the code itself, but it also has the dependencies, right? So when you're writing a Docker image has those as well. It has the code, it has, and also dependencies. The combination of that code and dependencies, right, is what the image is. And this image is being converted and it becomes an actual application, which is a container, right? With that container, right, you can actually create, I mean, you can see application, but it's not going to scale. It's not going to do anything. It's going to be static. You cannot manage it, you cannot do anything with it. For you to manage that container, you need an orchestrator. And the orchestrator that we're going to study is Kubernetes. Okay, so the registry, anyone has any other question? So the registries, the container registries are not just Docker Hub and Docker, it's not Docker Hub, right? You have container registries like Azure Container Registry, you have Google Container Registry, AWS also has one called Amazon Elastic Container Registry, which is ECL, right? So these are managed containers, right? These are managed containers. This organization manage the containers. So in some cases, you don't have to worry about maintaining your containers and so on. They are the ones responsible for the security of the images and all that. All you need to do is pay them the services and they manage your images in those containers. But one thing is, some organizations don't want other organizations like Amazon to manage their data or images because they can steal the images, right? It's a trade secret. So they want their own images, right? There are other organizations that if it's not really a secret, trade secret, right? They just push the images to be managed by those registries, managed registries. Microsoft, Azure, they're all they are in competition with other tech companies. So tech companies that are developing other applications would not want to store their applications in a managed container like this, right? They want to create theirs. Other organizations that they're not really tech organizations. For example, Walmart is not a tech organization, right? They don't care. All they want a Walmart um, application, that e-commerce application anyone can develop, right? So they can store their image in ECL, in AWS, it doesn't matter. But if you're developing a trade secret, you don't want to store it where people can get your trade secret and duplicate your work and so on and so forth. So those are managed services, managed registries. Amazon, Microsoft has one, Google has one, and so on and so forth. Okay. Let me see. Okay, so I think those are the theories. Basically, that's a theory about Docker and containers that I wanted to share with you people.